today we're going to do a group activity. What I have here is a set of eggs, Easter eggs, they're all decorated. So what I want you to do is work in groups and one person sort the eggs depending on the observable property. So observe the eggs and see if you can find any patterns. And I guess Brian can start first in this group. And then I want the other students to guess what the criteria was for Brian to sort the eggs that way. Yeah, there's 16 cards.
And which end is this?
Alright, so now you guys guess what the criteria was for Brian to sort it that way. What else? Although these are not the same as those.
These have
Okay. The circular jewels versus the Okay, good. Okay, now Teresa, try to sort them. It doesn't have, there's no correct answer. So there can be multiple ways to sort them. So when one person tries to sort it, I want the other person or the other group members to try to sort the eggs. Try to sort them in a different way. So, did you guys guess already? How to trace the sort of eggs?
I'm not sure.
Can you find the pattern? Yeah, see how they line up? They have the 3 bands and all the jewels line up in each band. Is that what it is? Okay. Okay. Why don't Sarah try this time?
Oh, I heard you.
So, Lauren, were you be able to guess or predict what this assortment was based on?
Yes.
According to the number of jewels?
Valence of jewels.
Valence of jewels? Alright, so why don't you guys share with the class what kind of assortment everyone based on? Like what were some observable properties on those eggs?
The shape of the jewels.
The shape of the jewels was one thing. What about anything else?
The background pattern.
The background pattern was different.
The number of jewels.
The number of jewels were different. So now I want you to pay attention to those properties. There's number of joules, there's different shape of joules, and there's different background on the eggs, right? So find the one that has the least number of band, like the horizontal band, and the least number of joule. Find that one that with the lowest number of joules and the least number of bands. All right, so yeah. So I'm giving you a little sorting sheet. So what you're going to do is place that least number of band and least number of joule eggs on the first column and first row. Okay, so place that one egg on, the first one. And then you're going to sort the eggs depending on my rule. There's a rule on the horizontal row, you're going to go from the least number of joules to the most number of joules. And another thing is, each row has to have the same shaped joule. Okay, so that's one rule for horizontal. And then for vertical, I want you to look through them, and the joules have to match up with the band. So the joules should all line up. And as you go down from top to bottom, the band number should increase. So try to sort them through based on those rules. Yeah, good. Yeah, that's what I meant by linearness. Yeah, they all have to be the same shape in that same row, and the number of joules should increase from left to right.
How do you want it going down?
So it goes, the bands increase as you go from top to bottom. Yeah, so how many bands would these be? Yeah. How many bands do these have? 1, 2, 3. So this should go to the third row. Yeah, all should line up. Yeah, those are 4 bands. Yeah. Yeah, that, where do you think that goes? Those have 2 bands. So I want you to double check from left to right to the bands line up and the same type of joules, and then the number increase from left to right, number of joules.
Yes.
And as you go from top to bottom in each column, the joules should have increasing number of joules and also increasing number of bands. Yeah, guys got it? Great, so I'm going to give you a periodic table. Each of you is going to get a periodic table, and maybe guess how you think the periodic table is organized. Based on the egg activity, based on sorting the eggs. Can anyone guess what kind of, doesn't have to be any chemistry related jargon. You can just guess based on the activity.
The numbers on the top right of the box seem to increase as you go left to right, and then down the rows seems to be ordered that way.
All right, so Brian noticed there was a number on top of the letters, and those numbers increase as you go from left to right. Right? What else do you notice about the periodic table or how they might be sorted?
The weight for the small number or increases.
Yeah, good. So there was another number. Teresa said there was a number beneath the letter, and those numbers also increase, seem to increase from left to right. Anything else? Good. So keeping that in mind, we are going to learn a little bit about a person who came up with the periodic table. So we're going to do I'm going to start with the first paragraph. I marked where you should begin. So follow along, and I want you guys to take turns. It's on page 106. It's from the Bill Bryson book, A Short History of Nearly Everything. So I'll start. Despite the occasional tidings up, chemistry by the second half of the 19th century was in something of a mess, which is why everybody was so pleased by the rise to prominence in 1869 of an odd and crazed-looking professor at the University of St. Petersburg named Dmitry Ivanovich Mendeleev. So Eric, why don't you start from the second paragraph?
Mendeleev, also sometimes spelled Mendeleev or Mendeleev, was born in 1834 in Tobolsk, the far west of Siberia, into a well-educated, reasonably prosperous, and very large family. So large, in fact, that history has lost track of exactly how many Mendeleevs there were. Some sources say there were 14 children, some say 17. All agree, at any rate, that Dmitri was the youngest. Luck was not always with the Mendeleevs. When Dmitri was small, his father, the headmaster of the local school, went blind, and his mother had to go out to work. Clearly an extraordinary woman, she eventually became the manager of a successful glass factory. All went well until 1848, when the factory burned down and the family was reduced to penury. Determined to get her youngest child an education, the indomitable Mrs. Mendeleev hitchhiked with young Dmitri 4,000 miles to St. Petersburg. That's equivalent to traveling from London to Equatorial Guinea, and deposited him at the Institute of Pedagogy. Worn out by her efforts, she died soon after.
Okay, what about Lauren? That's the next paragraph.
The short one, or do I go on to like middle and
Oh, you can do the book.
Mendeleev dutifully completed his studies and eventually landed a position at the local university. There he was competent but not terribly outstanding chemist, known more for his wild hair and beard, which he had trimmed just once a year, than for his gifts in laboratory. However, in 1869, at the age of 35, he began to toy with a way to arrange elements. At the time, the elements were normally grouped in two ways, either by atomic weight, using Avogadro's principle, or by common properties, whether they were metals or gases, for instance. Mendeleev's breakthrough was to see that the two could be combined in a single table.
All right, so Mendeleev was someone who sorted them by atomic weight, which what we saw beneath the letters. So atomic weight increases as you go from left to right. I could have gone like further, but you know.
We'll stop here.